In this video, I'll demonstrate how to read and write from scratch space using TEAL, and explain why and when you would use it. Scratch space can be thought of as temporary memory, which you can use to directly store values to and retrieve values from during evaluation. This allows you to manage up to 256 additional pieces of data without having to excessively manage the stack. You may want to think of them as somewhat similar to variables in high-level languages, but rather than having custom variable names, they're assigned slot numbers ranging from 0 to 255. Scratch space can be useful if you currently have a value on the top of the stack which you know you will need to use later, or you will need to use multiple times during the group's evaluation. For example, in this code snippet, we take two unsigned integers as arguments and calculate the product, which during evaluation will now be at the top of the stack. But what if we want to use this value in various checks throughout the rest of the code without having to calculate it each time we need it? We may want to perform checks such as, is it even, is it larger than 100, and is it equal to 88? To do this, we can store the result in scratch space after we first calculate it and whilst it's still on the top of the stack. Then, each time we need it, we can simply load the value from scratch space, which places it back on the top of the stack. Now when we check, is it even, is it larger than 100, and is it equal to 88, we don't have to perform the calculation each time. Another example would be using scratch space when creating loops. This allows you to keep track of how many iterations you've completed before breaking out of the loop, all while keeping the stack nice and clear and just using a single scratch space slot to hold the counter. Once again, remember that scratch space is temporary and can only be written to during the transaction's evaluation. Additionally, reading from the scratch space is only available during the current transaction and any transactions which follow it within the current atomic group. As a final example, here we're using the opcode gloads, which allows us to read the scratch space slot number 10 of the previous transaction within the same group. If the scratch space in question was never set, then this value defaults to 0.